Alright, so section 6.2 here, and we're looking at number 39, and the differential equation dy dx, and then we have y plus 5 times x plus 2. So if we separate variables here, we'll bring the y plus 5 on this side, bring the dx on that side, and look as such. And then from there, if we integrate both sides, get natural log of absolute value of y plus 5. And over here we'd get x squared over 2 plus 2x plus c.
I think they use, aren't you supposed to do the replace for u first?
I mean, you can, but ultimately the chain rule here, this is derivative 1. So you could use substitution and you'd get ln u, but then you'd put y plus 5 back in there, the du would not change anything. So ultimately, again, you can use the substitution here, but you don't really have to when the derivative is just 1. Think of the chain rule backwards. If I did natural log of this, I did the derivative, it'd be 1 over this times the derivative of this, it would just be 1. So again, if you want to, you could certainly do that and get ln u, but ultimately your du and dx would just replace each other straight up and you'd wind up with the same thing. So if you recognize that, then you don't have to bother with the use substitution part. Alright, so ultimately again our job here is just to solve this differential equation, which means that once we do that step we need to get the y by itself. So if we compose both sides with e, we're going to get y plus 5 over here, and this is going to be e to the x squared over 2 plus 2x plus c. And if we subtract 5, we'd have y alone. Keep in mind that that whole thing minus 5, the 5 doesn't go up with the argument up top or anything, because we're subtracting 5 from both sides here. Alright, and then depending on how it looked simplified, etc., ultimately remember what we usually do here when we have the e to some power where there's additions and subtractions, we can rewrite it as the individuals e powers multiplied as such. And then ultimately what is this right here? It's a constant. So what could we just call that constant? C. So we could write c to the c e to the x squared over 2 plus 2x minus 5. And I'm assuming in the back they probably put that back out to the plus instead of having 2 e bases, I would assume. It wouldn't make sense to leave it as e times e because we can write it as 1e with that power of those two it added. But ultimately that's how they got the c out in front, because they allowed that e to the c just to be c. Which again, you need to just use some mathematical license, if you will, to understand that e to the c is just a constant. So what can we call it? C. And with that said, just to remember also what I told you at the beginning of this whole thing is at this stage when we did the integration part, if they had given us an initial condition, we would actually find c right here. Okay? So we wouldn't even have had that issue if it was an initial value problem, because we would have already found c, and then we'd have some specific number there instead of c. But with that said, if we found it at this stage, we'd still wind up with the same answer. But it's easier to find c right at the beginning as soon as you integrate, which is at this stage right here. Questions on that one? What else? Cody? 36, we got definite integral u to the 10 radical theta, that is, and then 1 plus theta to 3 halves, all squared.
36.
Oh, darn it. So that would be 35. Do 36 instead. So this time it's negative pi to pi. We got cosine x. We got 4 plus 3 sine x dx. We'll do the radical. Alright, so ultimately here again we're going to need to make a substitution here that will allow us to find an answer to this stuff. And I guess again, keeping in mind in terms of letting something equal u, what would be something that would be good to let equal u, knowing that if we did let it equal u, its derivative would have to be something that's available too to get rid of the dx part. So ultimately the whole argument under here, if I do it 4 plus 3 sine x, wouldn't the du here be 3 cosine x dx, which would be very related to the top and the dx part? And we'd also have, in our integral, we'd have radical u on the bottom, which is convenient because if all our integrand was is 1 over radical u, that would be easy to anti-differentiate because it's a power function. Okay. But the issue here is how do we get rid of cosine x dx? Well, this is 3 cosine x dx. If I just did 1/3 du, wouldn't that equal cosine x dx? Divide both sides by 3. And so therefore, if I plugged in my 1/3 and my du in place of my cosine x dx, then I would have my integral substituted properly. And remember, like I showed you yesterday, we don't put numbers on there. If we put numbers on there, it's not right. So don't put numbers on there. It's going to be marked wrong. Okay. You substituted u here. That means that the negative pi and the pi are not what goes on the upper and lower limits. Just leave them as dashes for the time being. And then if we integrate here, we could rewrite this as u to the negative 1/2. And so since that's u to the negative 1/2, the antiderivative would be u to the 1/2 over a half. It would be 2 radical u. And again, even at that point, we still don't put numbers in there because we have u values, not x values. And then if we put finally back in our 3 sine x, 4 plus 3 sine x that is, now we can put our negative pi and our pi in there. Alright, so let's see what happens when we evaluate. If we put a pi in here, sine of pi we know is 0. So ultimately we'd have a square root of 4. Underneath there is 4 only. So it would be 2 times 2, which would be 4. And then we're subtracting from that. If we put negative pi in there, we're going to get 0 again. And so ultimately we're going to get 2 times 2 again, which would be 4 here. And ultimately, what is that going to wind up giving us? It's going to give us 0. So what might that tell us about this function then, knowing that the answer to this is 0? So that would be odd. Right? Symmetric about the origin. Okay. It's odd. It's going to be symmetric about the origin, which means that there's as much negative area as positive area when we're going from negative pi to pi. Okay. That means that our answer should be 0. Thinking if this is on a calculator test, could we verify that? You know, we can verify any definite integral because we could type that in our calculator and do our integral command, couldn't we? Verify that it's 0. We could also look at the graph and see that, in fact, it looks odd that there is the same amount of area on the left as there is on the right, and verify that our work makes sense. Huh?
Is there one way that's like better than the other? Like instead of doing like finding the integral endpoints like right away? Like the other method?
I usually do it this way myself, but that doesn't make it right. So there is no right or wrong. You can either way work. So it's up to you on what you prefer. I prefer this way, but
I'll go.
do it the other. It's up to you. As long as you get it right and the work makes sense, and it's good. So like I said, there's 2 ways. All right, what else? Mike?
Can you do the number 2 on click, please?
Yeah, let's finish off this book first, though. Anything else from this book assignment before we move to the worksheets?
42.
On 42, get again differential equation, and issue is you're separating the variables, and ultimately the key element here is to make sure that we recognize that something can be done with this. Otherwise, we're not going to be able to separate those x's and y's. And how can I rewrite e to the x minus y? So if I did e to the x times e to the y, ultimately I could times by negative y if I wanted to, but ultimately wouldn't that be this? I had e to the x times e to the negative y. I use my rules of exponents, which ultimately allows me to multiply e to the y dy over here and then multiply the dx on this side. And then with that, the antiderivatives are just e to the y and then e to the x plus c. One thing to note on this, if we're going to solve this, we know that we need to take natural log of both sides. When we take the natural log of the left, we get y, of course. When we take the natural log of the right, it's the natural log of e to the x plus c. Okay? The natural log is not being multiplied by that quantity, so there is no distributive property here. We can't do natural log of e to the x and then natural log of c because that's not one of the properties of logarithms that we have. Okay? We can take the logarithm of product and do something with that, but when we have a logarithm of a sum, right, That's the answer. You can't distribute the natural log into the parentheses and get two different answers there, because that's not a property of logarithms. It's not a multiplication problem here, it's a logarithm problem. So ultimately that would do it. What else? And 44, you got 4 radical y, ln x over x. So ultimately we would, separating, we'd have 1 over radical y dy over here, 4 ln x over x dx over here. And similarly, just anti-differentiate. Antiderivative of y to the negative 1/2, we just did that a minute ago, is 2 radical y. And then in this one, we would have to substitute here because we have ln x over x. If we let u equal ln x, of course, though, that equals du is 1 over x dx, which is convenient because that's what I have here. I have over x dx as my other stuff besides the natural log. And the 4 can come out, so we just have 4. And then when we'd have simply just u du here. Again, the ln x would get replaced by u. The over x dx part is du. And again, the 4 can go out, so if we anti-differentiate, we're going to wind up with 2 radical y on this side, 4 u squared over 2 on this side plus c. Of course, our u is natural log x. And from there, in terms of simplifying, we would divide by 2. If we divided by 2, that would make 4 and 2 both go away altogether, so we'd have ln x all squared plus c. And if we square both sides, ln x squared plus c all squared. Give us our y by itself. And again, just a reminder again, when I did the divided by 2 part here, how come I didn't divide the c by 2? The c divided by 2 is still a constant, still c.
On your third line from the bottom where it has 4 ln x, is that squared?
Yes. Remember, it's u squared over 2, the antiderivative of u. So. All right. How about the other book? Worksheet problems. It's on page 340. 343, right?
Yeah.
So from the book, 7.2, we're looking at number 75, you said?
Yeah.
75 says we got from 5 to 3 of f of x minus a dx equals 7. And it says that a is a constant. And ultimately the question then is what is the integral from 3 minus a to 5 minus a of f of x dx? Alright, so let's think about picture-wise what this would mean if I had this function here compared to f of x. Ultimately, if I have f of x minus a, and I know about translations, which hopefully we do, that means that we move the f function would move a places to the right, if you will. Okay. So let's just say, for argument's sake, think about a picture of, let's say our normal sine function on 0 to 5. Okay. If I were to move that 5 places to the right, okay, ultimately 0 to pi, my new picture would look something like that. Okay. And again, I'm just saying 5 places just to pick some random a. Okay. So ultimately this would be 0, this would be pi, this would be 5, this would be pi plus 5. True? So if I just take a specific function, maybe I can have some insight into what this general function is going to be like in terms of the answer to that question. So keep in mind that if this is my, again, my original function, right? And this is my translated function, okay? And keep in mind the area of this they're saying is 7. What would be the area of this? It would be 7 also. Again, we're just moving it. So the area part would not be any different, okay? And so keep in mind that in the expression here, when we go from, I'll get these backwards. Let's do it here in 5 here, sorry. So when I go from 3 to 5 for this function and the area is 7, okay, the translated function, which means ultimately the function that it came from, the one that's left of the given function here, okay, and if I did 3 minus a and 5 minus a, what would that do to my limits? That would take my 3 and 5 and move them back to where I started, wouldn't it? So ultimately, wouldn't this expression right here and this expression right here give me the same answer? So remember, this is the original function, okay, that is left, and this is the new function that's right. Okay, ultimately, they're the same function though, because remember, we got f of x minus a. This is going to be moved right. So just like I said in this picture, if I moved it right to these new limits, okay, if I subtracted that same number from my limits, wouldn't that bring me back to where the starting point was, if you will? And so therefore, what could be said about the answer to that? It's got to be also what? Got to be also 7. So again, it's essentially just a translation problem, recognizing that these two functions, you know, if I translate it, it's not going to change the area. All right. Questions on that one? What else? Mike, do you have one? Mike?
Quick quiz number 2.
Devin, is that one?
Yeah.
We're not going to do that one, actually. I think it's page 353, right? Go ahead and cross that one out on your list. We're not going to do number 2 on that. Others from the regular part of the quick quiz? Justin?
I have a question just on this. So basically, if you minus a from both the top and the bottom, it's basically not going to change the area. Is that basically what you're saying?
Between these two, between the original and the one that's translated right, okay, ultimately what we're doing is we're just translating it back left. Now, by doing this basically negates what we did right here. This translates right, this translates back to the left. So ultimately these two functions are, you know, same shape like I did with the sign. And ultimately, no matter what those shapes were, it'd be exactly the same. And that, from 3 to 5 of that, as from this set on the regular function. All right, others on the page 343? Yeah, we'll get to that. Let me finish this page first, then we'll go quick quiz.
71.
71 says true or false. We got from 0 to pi over 4, tangent, cubed x, secant, squared x, dx. It says that the answer, or the substituted integral, is from 0 to pi over 4 of u cubed du. And so again, the question is, are those two things equal? Well, if we let our u equal tangent x here, our du would certainly be secant squared x dx, which means ultimately I'd have u cubed du here. And so my substituted integral would look like that, exactly like what I have on the right. However, there's one issue. And what issue do we have with this? The 0 and the pi over 4. That can't stay 0 and pi over 4 unless the function is just x. True? We don't change the function at all, then they stay. But ultimately, the limits are wrong, aren't they? Okay. If we wanted to write it in u, okay, we would have to put the 0 and the pi over 4 into the tangent function and see what our new limits are. In this case, it would be 0 because tangent of 0 is 0. But if I put pi over 4 into tangent, I'm going to get 1. And so that would be the correct integral instead of that. So therefore, the sentence would be false. Others in that group? Alright, how about anything else? We'll start with a quick quiz then. Evan, you said number what? And number 3, quick quiz, we have integral of x e to the 2x dx. And we want to find the answer to that essentially. So we anti-differentiate here, we'd want to use u equals 2x possibly. If we used u equals 2x here, then the derivative would be 2 du, which ultimately would not give us anything good, would it? Seeing as how we have an x to get rid of along with the dx. Okay. So that would not work. And so therefore, if we try to do that substitution, again, the 2 du is not going to help us get rid of the dx. Okay. Now, one thing that we might be able to do here too is if we just wrote it as x and then e to the u, and we replace the 2 dx, I should have wrote. If we replace the dx with a half du, we could get rid of everything but that x. And the other thing we could do is we could write u over 2 equals x, and we could replace the x. But if we did that, notice what would happen. If we take that 2 out of there, we'd have u e to the u du. How does that compare to the original? That's really the same thing, isn't it? So again, we could substitute and we could get rid of the x's in this case, but in this particular case, it doesn't really give us anything that's helpful, does it? Because we're still in the same predicament. Okay. All right. And so question is then, well, what in the world do we do next? Okay. Now the answer is that we solve it next year when we have BC, because it's a BC problem. This is actually an integration by parts problem, which you do not need to know for the AB test. So you can cross out number 3 also. So 2 and 3 are out. I think that number 2 is from that section also. For the slope field part, I mean, we can certainly do that because you can draw that curve there. And for part B on that, we got there's a value b for which y equals 2x plus b is a solution to this differential equation, and we want to find that b. Ultimately, if the I guess what we want to look at here is the fact that the equation they gave us was a line. So if you look at that slope field, is there anywhere that it looks linear, like say with a slope of 2 perhaps? Looks like where it goes through that top point that's marked down there, it looks like it's linear going through that point, doesn't it? Okay. So again, what might we want to pick for our b value there? Okay, we ultimately, again, we know that that the derivative here is 2 because of the fact that we have our slope is 2. Okay, so the derivative in that area would be 2. So that means that if we use our differential equation here, let's see if we can do some substitution here. We know that the derivative in general is 2y minus 4x. Keep that in mind. Right? And we know that with this point, with the point that we're looking for ultimately here, we know that the equation for it is this because they told us that. We know the derivative is 2, and if we put in our what y equals, which is 2x plus b, we can introduce that b value there. Okay, and keeping that in mind, if we look at our x, okay, remember our x here, we're looking for a y-intercept here, aren't we? So what would x be if we're looking for the y-intercept? Yeah, x would be 0, so ultimately our sentence would read 2 and then b and then minus 0. So ultimately it would be 2 equals 2b, so b would equal 1. Alright, and again, just to make sure that ultimately, if you look at the scale that they have on there, I mean, we can see that really, I mean, 1 or something right around 1 would be the only option, wouldn't it? You can see the scale on there, they have 1, that's that point that they have marked as 0, 1. And it looks like 2x plus 1 going through that point, doesn't it? So it looks like that would be the exact solution through that point. Okay. And you'll notice that they didn't ask us to actually solve that differential equation because that particular differential equation is not separable. Okay. And so you'll you'll have to wait until you take a class on differential equations to deal with that in terms of the algebra and calculus. For the time being, we can only conjecture solutions with slope fields and so on. Alright, and then let's see if we can answer the next part here. It says, let g be the function that satisfies the given differential equation with the initial condition 0, 0. So it appears from the slope field that g has a local maximum at the point 0, 0. Okay. And it says, using the differential equation, prove analytically that this is so. So for this part C, if we take our differential equation, and again our differential equation being this, true. And if we try at 0, 0, wouldn't the dy dx be 0? Which then, keeping in mind if the slope is 0 here, what does that indicate? That indicates that we have that would be a critical point, wouldn't it? Anywhere the derivative equals 0 is a critical point. Okay, so it might be a maximum or a minimum, possibly. Alright, and we could tell there's, I guess, a couple ways we could decide on whether or not it was. We could look at what's the derivative ultimately immediately to the left and right of that would be one way we could test. Okay. So if we picked a point immediately to the left of 0, 0, let's say negative 1, 0, for instance. If we put negative 1, 0 in there, we get that. Negative 1 for x, 0 for y. We would get negative negative 4. We'd get 4, which ultimately is a positive answer. True? So that means to the left of this point, the derivative is positive, which is good because that means it's increasing, right? And if we go to the left, like 1, 0, and we put in 4 and 1, we're going to get negative 4, which ultimately means that to the left of the, or to the right of the point in question, the derivative is negative. So if the derivative is positive, becomes 0, and then is negative, what does that prove about this point 0, 0? It's got to be maximum, doesn't it? Is our first derivative test. And if we made a number line, it would look like this, wouldn't it? If this was our f prime or dy dx, if you will, our 0 here would be positive then negative. So ultimately, what would we have? We have a maximum there at 0, 0. Okay. And again, the two criteria there are the fact that the derivative equals 0 there, so that makes it a candidate. And to the left, the derivative is positive. To the right, the derivative is negative, which again indicates that we have a maximum instead of a minimum or a flat spot. Others? Number 1, we have which of the following differential equations produces a slope field. Now, just looking at that, which ones can we rule out, or can we rule out any at this point? And how come? Because it's not. I mean, these all have both x and y in them, right? Okay. So even though it looks like down the columns we have similarity down the columns, which means that's usually only in one variable. Okay. In this particular case, though, this one was produced by one that has both variables, because again, all 5 choices have both variables. So, in terms of ruling in and ruling out here, you know, I guess the best bet is just pick a point. So this point, let's say we just pick, you know, they don't tell you what the scale is here on anything, so just, I guess, just estimate those to be, every slope field to be 1 and 1, 2 and 2, and so on, you know, the points in question. So let's pick, if we can move over, let's say 1, 2, 3, 4, 5. Say we go 5, 2 for argument's sake. So if we plug in 5, 2, if you go 5 slashes to the right and 2 up, it looks like the slope looks something like that, doesn't it? So at least positive and fairly steep. So let's see if that happens with our A is y minus 3x. So if we do that, it'd be 2 minus 3 times 5. That would be negative 13. So how does A match up? That would never produce that at 5, 2, would it? Okay. Alright, the next one is y minus x over 3. If we do that, we're going to get y, which is 2, 5 over 3. Ultimately, it would be 1 2/3. We'd get a third. And that looks, to me, looks quite a bit steeper than a third. So I would say that one's probably not the right answer. got y plus x over 3 be 2 plus 5/3, which ultimately would be 2 plus 1 2/3 would be 3 2/3. Now 3 2/3, I could live with that if that was a choice, and that may or may not be the right answer, but let's see if there's a better one. So that one's ultimately still in, these two are out. Y, isn't that the same, C and D?
Yeah, I think so.
Weird. Wonder what it was supposed to be, that's obviously a misprint. So I guess those are both in, and as it turns out, it's not the right answer either way. But and if we do x minus y over 3, we'd get 5 minus 2/3, which ultimately would be 4 1/3. Put our 5, 2 in there. And again, either one of these would be reasonable. It's very hard to tell which one's the right one if they're both the positive slope there. Cool. So if we got it ruled, I guess, you know, C and D, I guess, together are in because they're the same answer. But so either way, we got to pick a different point then to rule one of those in and one of them out. Okay. So maybe pick one that has a negative slope, possibly. So let's go, if we go on the left side, 1, 2, 3, 4, 5. And say we go -5, 2. If we go -5, 2 with these same differential equations, we're going to wind up with, again, our 2 would be here. It'd be -5/3. And if we do 2 minus 5/3, keep in mind that's 1 2/3. Wouldn't we get positive 1/3 there? And so therefore, -5, 2 have the right slope. So remember, with -5, 2, our slope looks like this. And that certainly isn't positive 1/3, is it? And if we try this one, we'd have 5, -5 that is, minus, and then 2/3 here, be -5 2/3, which ultimately that would match up with a negative slope here. And so that means the only one that would make any sense at all would be the choice E. Others?